So yeah, a few organizational things again. I mentioned it's okay. You can edit
you're
later.
rolling.
Yeah. So it works. No, it's recording.
Yeah.
Good. Yeah. So like I said, I've been talking about and writing and trying to write and talk and convince people about this object-oriented programming concept, which I think is the right concept comparing to the traditional object-oriented programming. And I've been doing it in many different countries and online, but nothing here, nothing in this territory. That's why I decided to organize this series of meetups where I can build a community of people who actually share my ideas and not necessarily share all of them, but they are interested in the ideas. And that's why the meetups. So there are not so many people here today, but I think that the community will grow and we'll get to a few hundred people in like half a year or maybe sooner. So I prepared a presentation for about half an hour where it's going to be about Anemic objects and object-oriented programming. And then we'll discuss. It's about half an hour talking and then discussion for another half an hour, and then I'll let you go. Unfortunately, we don't have food and drinks because the room doesn't allow that. But the next time we'll get another room where the food and drinks are allowed. We didn't know about that, so we didn't know about that restriction, so we got this room. Anyway, so that's the structure of my talk. So first of all, we'll discuss, I'll explain how I understand procedural programming. The next one, I'll explain how I understand object-oriented programming, object thinking actually, and the difference between them. Then I'll show you a small practical example in Java. I think most of you, well, it's not going to be a lot of code. It's just Java as a language, which is easy to read. And then I'll try to explain what is Anemic model and how it's, what the problem with it. And then we'll do the refactoring, and I'll show how we can get rid of that Anemic model and how the code will be way more object-oriented and way better. And then the questions. That's the structure. So that's what I understand about procedural programming. When I was preparing that, I read a few articles about procedural programming, some Wikipedia pages, and that's my summary of what procedural programming is. There are 4 things this is my personal understanding. This is not from any official source. But that's what I understand. So first of all, in procedural programming, the code is the king. So the code is the main part of the software. And we always, when we write software, when we create the application, we always focus on how things work. This is the verb how. It basically defines the procedural programming. So in procedural programming, we always talk about the execution flow. So we know how we start, we know the point of start, we know where we're getting at, and it's always about how we manage the data. So the code is the king and the data is something secondary. So the code controls the data. That's procedural. The second one is it's imperative, which means that there's imperative and declarative. There are 2 things, 2 programming paradigms. Imperative means that we're always telling what needs to be done instead of saying how the result looks. So the imperative procedural programming is imperative. I'll show you practical examples and compare them. Now I'm just summarizing what it is. Number 3, it's the procedural programming. It resembles, it looks like the hardware works. So in the hardware, we have the code and we have the data. And that's where procedural programming came from. So that's the hardware platform. It's made like that. In the hardware, we have the piece of memory designed for the data, so we keep the data over there. And then we have the execution flow, the code, which goes statement by statement, operator by operator, directive by directive in the assembly language or whatever. And this is how maybe not most, but all of the hardware works. And that's how procedural programming was designed. So they basically made it after the hardware. First of all, they made the hardware like 50 or 60 years ago. And then they introduced all the programming languages, which are coming from the architecture of the hardware. So by writing procedural code, we always are thinking like computers. So we are just giving instructions to computers. Just take this data from here, move that data over there, modify the data. We're always understanding, we're always in a direct contact with the computer. We are like instructors for the computer, and the computer is the machine, the executor of our instructions, of our will. So the whole paradigm is, it looks like the hardware, like the machine. That's the procedural programming. And number 4, the data is visible. So it's a clear separation of the code and data, and it's always clear for the programmer. We always can see the data. So the data is obvious for us that this is the data and this is the code. The code gets the data, modifies it, transfers it somewhere, but we always see the data. The data stays aside from the code and is always visible where the data are, where the data is. That's my understanding of procedural programming. That's 4 things which are important, I believe. And this is object-oriented. It's completely different. Object-oriented programming, in the object-oriented programming, first of all, it's not the code who is the king, but it's the object. I didn't say the data because usually it's compared code versus data. So, but in this case, we can say the data is king. But in object-oriented programming, it's not data; it's the object. But in reality, it's we can say it's not the data, but a thing, an entity, something. So it's something which is a noun, a thing, and we call it an object, is a king. So the key question we're asking is what, not how, but what. So we're not saying how we're going to achieve the result. We're saying what is the result we're going to achieve. This is the big difference between object programming, object thinking, and procedural. The same as functional. In procedural programming, we're saying how. In functional programming, we're always saying what. So object and functional, they stay at the same side of the equation. So on the left side, we can say this is procedural, extreme, where we're telling the computer what to do, and on the other side, how to do it. On the other side, we're talking about what needs to be done. So functional and object programming, they're very close to each other. So the object is the king, not the code. So we're not focusing ourselves on how this result will be achieved, what kind of code we need to write. We're always thinking about what it's going to be. And I'll show you now the Java example to make it more clear. The second one is declarative. So we're not telling what to do, we're declaring, defining the result of our execution. Not defining how it's going to be executed, but more defining what needs to be, what is going to be in the result. The second one, the third one is that object-oriented programming resembles real world. Now we are thinking not in computer operators, not in the machine, not in the architecture of the computer. We're thinking about real things from the real world. So we are talking not about pieces of memory, but we are talking about the elements of the real world, how it looks for us as human, and then we decide how to combine it together to build the software. So that's the main shift of our mindset. So we stop thinking as computers and we start thinking as real world elements. And object programming is designed, should be designed, because this whole presentation is about how we misunderstand object programming. So now I'm giving you my understanding of object-oriented programming now, and then I'll show you how most of Java programmers and a lot of the real software misunderstand that. So in a perfect object, in perfect OOP, objects they are designed without any thinking about how they will work in the computer. So we shouldn't think about how these objects will be allocated in memory. We shouldn't think about how these operators and processor, CPU instructions will manage them. We're thinking about what they are and how they resemble the real world. That's how OOP should work. And number 4, data is hidden. So we're not supposed to see the data in OOP. We're not supposed to see clearly the code is here, the data is here. We're supposed to see the object which hides the data inside it and just exposes the behavior. So we just have an object which behaves somehow for us, but we don't see the data inside the object. We are not supposed to know what's inside there. We just see the object. So the data is hidden. So that's 4 things which I think is different. And now the practical example. On the left side, I put the Java code for procedural programming. And on the right side, this code is for object-oriented programming. I'm just doing 3 plus 5. But on the left side, it's imperative, it's procedural, it's machine thinking about computer, like how it is going to be executed, and the data is visible. On the right side, it's object-oriented, so now we're talking not about how this summary will be calculated, not about how to execute 3 plus 5 and get the result here, but we are talking what is the result. We're saying that the result of this summary is the object sum, which behaves like another number, which is probably a summary of these two numbers. So there is no operator here. So obviously there's going to be technically the operator inside. Something will happen inside. And the machine, of course, the computer will, of course, execute the operator of adding two numbers. But for the programmer, for the person who is designing that software, this line is procedural because the focus is on this operator. So we are telling the computer that get this number, get another number, put them together, and save the result into variable A. So the data is visible. We can see what's going to happen. We can see that the data will be retrieved. Well, some number 3 will be from here, number 5 from there. Then the computer will execute the operator plus and save it to the variable A. On the right side, it's not happening. We're just declaring what the result is. The result is a summary of 3 and 5. So we're not saying how exactly that will be calculated. We're just declaring. For the functional programming, it will look almost the same. In the Lisp, for example, not in Java, but in Lisp, you will also write, but the syntax will be different. There's also be the declaration of a summary. So here we declare the result, and here we're telling the computer how the result to be calculated. And that's the difference. And this one is bad, this one is right. I mean, it's not, I'm not saying that this is, I'm not saying, yes, I'm saying it's bad and it's right, but it's not just bad because I don't like it, but that's my next slide is about. I think, that's my understanding, again, this is my opinion, is that with procedural programming, the problem is that the code, when you write the procedural code, the bigger it becomes, the more the complexity grows. So big software, big amount of software in the procedural style will eventually cause a lot of complexity, and the code will become less and less maintainable. That's what the problem with procedural programming is. And that's what happened, I believe, a long time ago when the object-oriented and functional and logical and all other different programming paradigms were introduced. Because people started to realize, I was too young that time, but I think that what happened. That's my understanding of that. That people started to realize that the more code you write, the more difficult it is to understand the code. Because the data has no semantic. That I think is the real cause of the real problem. So the code getting bigger, and every time when you're looking at the piece of code, you don't know exactly what this data mean at a particular point of time, because data are so visible, the data is accessible by so many pieces in the code, and that's why the data is not hidden, and that's why the data basically lose the semantics. So we don't know what the data means in any particular point of time. Something like that. So the bigger the code, the bigger the complexity, because I think in the procedural programming, because data has no semantic. And if you look at this example again, I'm switching back. Here, I would say we don't know what that means. We know how it was calculated. So we know how we got the two numbers and put them together. In this case, we know that the result of this is a summary of two numbers. So maybe it's not a good example because it's too simple, but let me show you more, and then this statement will be more clear. So object-oriented programming was supposed to become a solution. That's how it was, I don't know, 40 years ago, 30 years ago when the OOP was introduced. So it was supposed to become a solution. So we should stop writing procedural code, and we should stop just manipulating data and moving data from one place to another, just moving data and focusing on code. Instead, we should hide our data and focus on what our objects are. So just build objects and let them communicate to each other, instead of us controlling how the data go from certain pieces of memory from left to right. But it didn't happen, I think. What I see right now in the Java world, because I'm writing mostly Java software, and I think that it's not happening right now, and most of the code which we have now is not really that object-oriented programming as it was planned to be. So we plan to have OOP as a solution, like the solution which would help us to get rid of procedural code, but in reality we still have procedural code in the Java world. So the majority of Java software now is actually procedural, not object-oriented. And this is what I found on Wikipedia yesterday. I was looking at the article which is about procedural programming, and the article says objects expose behavior and data. So that is what I think is really wrong about the current situation in object-oriented programming. Because objects are not supposed to expose data. The objects are supposed to hide data. But even the Wikipedia says that objects expose data. So this is like a mistake which a lot of programmers make, and even the Wikipedia and many books about OOP and many books about Java, they say that objects expose behavior through methods and data through attributes or members. But this is not what, like with everything I explained before, it shouldn't happen. That the objects are supposed to hide data and not let other objects know what's going on inside, to know what the data, what this data is about. So the objects should only expose the behavior, not the data. But even the Wikipedia says so. And that exact statement leads to creating this anemic objects, which we're going to talk about now, which is I'm getting to the main subject. So the Wikipedia is wrong, and that's why it's happening. And now the real code. I hope the camera can catch that. So it's just a small example of, let's say we want to get some data from the API, so we want to make a connection to some API in the network. We want to retrieve the book, the information about the book from that API, let's say in JSON format or some format. And then we want to store that data, that book, into the database. Pretty simple example. So we connect somewhere, we get the JSON from the network, then we parse that JSON, and then we're trying to store it to the database. So this is the code which stays in the center of the picture. So that's what I'm saying. This is procedural code, this is procedural programming right now. The code is king. So the code is the main part. The data which comes from the API and goes to the database, this is the data which is like a supplementary, which is the secondary thing. So the code is the main thing, and data is secondary. So this is the procedure, that one is procedure or a collection of procedures, and this is the procedure. So one procedure makes a call to another one and says, give me the piece of data back. And the piece of data comes back, and this piece of data called book. So the semantic of this data is not really, there is some semantic because we have the title, it's called book, and then it's called title, ISBN, all the things. But where it's coming from, this information is lost. So as soon as we get this book from the API, we don't know anymore that the data came from the API. So this is the semantic I'm talking about. So we know that this data which is coming from the API contains the ISBN and the title, but the semantic of the full picture of what's going on is lost. So this code here, if I remove this line, for example, we don't know anymore where this book is coming from. So if we don't know that the book is retrieved from the API, then we lose the semantic. And that's why the code is complex. That's why the more lines I put in here, the more complex the code will become. It will be more more and more difficult to understand what's going on. So this is the procedure. We get the book 1 from the API, then we build the book 2, we move one data from another, we get the data from here, I put it into book 2, and I store it to the database. This is the classic example of anemic model. So both objects, book 1 and book 2, are not really objects. They are just plain data structures. They don't know anything about what's going on. They don't know this. Book 1 doesn't know that it was retrieved from the API. It doesn't have that information. It just is a data structure which the data were injected into it by the API and then retrieved by this code. The same for the book 2. The book 2 doesn't understand, doesn't know that it goes to the database. It's just a data structure with no semantic, with no knowledge about what's going on. This procedure just injects the data into this object and then pass this object to another procedure, and then that procedure fetches the data out of this object, out of this anemic object, and does something else. So this is the classic example of anemic object. And this is how it would be defined inside. Again, it's Java. So let's say it's class. Even though it's called class, it's not really a class. It's not really an object, but it's just a data structure. And in the primitive approach, it's a book with two public attributes, which we just can use for to temporarily store some data in them. And even if we make this book more powerful and define so-called setters and getters, then in this case it's still anemic object. It's still not an object but a data structure. It's still a container for data. Because these getters and setters, they don't actually add any knowledge to the object about what it's about. So this book, it doesn't know that it's coming from the API. It doesn't know that it goes to the database. It's just a container which temporarily holds the data between two procedures. So we don't resolve the complexity problem at all. It's still two procedures or three procedures where the code is king. So the code is the main part. The code executes and the code moves data from left to right, but the data doesn't know what's going on. The data has no semantics still. And that's why the whole code, the whole application will be more and more complex with time. The bigger it becomes. So even though if it's like that or like that, it doesn't matter. Because the book doesn't know, the book has no context. It doesn't know what's going on. Procedures control the data, not the other way around. And yeah, so because of that, I see three problems with that anemic model. Now I'll discuss them, and then I'll show you the example of code which solved that, and we're done. So first of all, data is still visible. So if you look at this code again, I can jump a few slides back. So the data is still visible, which means that we get the data from the API, and then we manage this data over here, and we see that data like wide open. So the data is actually not hidden anywhere. We can still see the data like in front of us. So we can see the ISBN. We move the data, we transfer the data from these three procedures, and it's always clear. The data is always open to us, and we can always touch them. We actually didn't hide anything. Even though we have these so-called objects, which are not actually objects but containers, but these containers are wide open for us. So we know what's going on in them. So we transfer them. Yeah, it looks like we hide data. Even we making these getters and setters, it looks like the definition here is private. Even though it's private, it's still open. It's still a container of data. So we didn't actually manage to hide the data like we're supposed to do in object-oriented programming. So data is still visible. The second problem, it's still imperative. So we are giving instructions to our computer and saying, go to another procedure and get us the piece of data. And now get the data here and move it from here to there. And then the next line, move it again from here to there. And then go to another procedure and call that procedure and pass that parameter there. It's still imperative programming. It's the procedural programming. Even though it's Java, even though the syntax is Java, but it's imperative programming like it would be done in assembly language. If you transfer that stuff to assembly language, it will look very, very similar to this code. In assembly, it will be the call, it will be the move operator, and another call. So it will look exactly the same. Another maybe not 4 lines of code. It's going to be like maybe 40 lines of code. But it's still going to be exactly the same structure. It will be just sequential execution from top to down, one by one, imperative. So we are telling the computer what to do for us. And this is not object-oriented programming, it's procedural. And the last one, it's no semantic. Like I said, this book thing, they don't know anything about what's going on. They're just containers. If you stop somewhere here and then ask this book, like, what do you think about yourself, or do something else, they don't know what to do because there is no connection between this book and the API. There's no connection from this book to the procedure. The book is just something very isolated, which is no so much of a difference between the book and just an array in memory. So if you take an array in memory or just a few bytes in memory and this book class, the book object, there's not so much of a difference. They are both quite dumb and they just both don't understand anything. They have very passive data structures. There's no code in there. This is called anemic model. So there are 3 problems, which I'm saying that by using that approach, by using structures like this, by using objects with getters and setters, we automatically move ourselves from object-oriented programming to procedural programming. So every time you look at the code in Java or any other language, if you see that your object actually looks like a container of data where you want to get something and get and set from there, it immediately should tell you that you're writing procedural code. So it's not object-oriented anymore. And there's a lot of code like that in Java. If you're writing Java, you should probably see that. You look at the modern Java libraries, Spring, Hadoop, and there are many others, which I'm working with. They're all full of these getters and setters and these Anemic objects, like containers of data. If you look at, there are many, and new libraries are created like every day. And people keep using that. So they make this, also sometimes the name for that is data transfer object. Probably you've heard about that pattern, DTO. So this is the data transfer object. So the object which is supposed to just transfer data from one piece to another. But this very idea of transferring data from one piece to another is procedural. So as soon as we are doing that, it means that we are writing procedural code. And now, my last few slides to show what I would do instead. How I would do it in an object-oriented way. Exactly the same amount of code. So that's what I would do. I would create two classes, and one of them would be called API book, another one would be called database book. So the API book object knows how to talk to the API and how to get the data from the API. So every time we need anything from that book, we just create an instance of this API book, and then we communicate with this API book, and the API book knows where to find the API. So it's not like the book is here and the API is there and we are in charge of connecting them together. We're like asking the API to build us the book and then give it to us and we decide what to do. We build an API book which knows where the API is. So I don't see the API anymore. I don't know where it is. Only the book, an object which is aware of where the API is, I make it this object, and then I talk to this object and the object talks to the API. So it's not dumb anymore, it's not the container anymore. It's the book which knows how to get the data, how to find the data, how to fetch them from the internet, and how to present it to me. And then another object which is called database book. And this database book, when I'm talking to the database book, it will get the data from the encapsulated book, and at the same time, while working, it will save the data to the database. So this guy talks to the database, this one talks to the API. And me, as a client of them both here, I just build an object, I declare, there's no imperative anymore. I don't tell them how to communicate. I don't connect them together through the procedure. I don't connect one piece of code which talks to the database to another piece of code which talks to the API. I just declare what it's going to be. So I'm saying with this statement, what is the book? The book is the database book with the API book inside. So I just declare my object. And then this object starts to work for me, to behave somehow, to expose some behavior for me. Not the data, but behavior. And that behavior will be different in this, in this example and that example. Now I'll show you what the code is inside here, what the code is inside there. So don't get me wrong, there's still a CPU inside. Of course, we're still gonna do the fetching the data from the API, and we're still gonna save to the database. But the way it's presented for the end user, it's very different. In this case, it's declarative. In this case, the data is hidden, so I don't know what I don't see the transfer of this data between two pieces of code, like we saw before. So here's what it's going to be in the API book piece of code. So the API book, it implements the book, so it looks like a book for any user. So any user can create this API book object, and then can say, give me your title. What's your title? What's going to happen? It's going to be the HTTP request to the server. It's going to be parsing of the JSON, whatever, and then it's going to return the title. So the code, the API, the interaction with the API, or maybe the entire API, is encapsulated inside the API book. On the surface, when you're asking me for my title, I'm going to give you the title, but you're not going to know where I found the title. You're not going to see, this semantic will be mine. So I know what's going on. I am fully me as an object. So I'm as a book, I'm fully aware of where did I get the data. I know where this data is. Only I know where the data is. Only I'm in charge of that data, not anyone else. So I'm not, in the previous examples, you saw this book was just a simple container which just stored some data and didn't know about where the data coming from. In this case, the book encapsulates all that and knows everything about the data. So semantic is here. The data has the semantic. That's one example. That's what's going to happen in the API book. And this is what's going to happen in the DB book. That's my final slide. So the database book is also, it also implements book. It also looks like a book. So it also has the title method. But it encapsulates another book, which is API book, for example. So when you're asking for the title, it loads the title from the encapsulated book, and then it saves it to the database, and then returns the title on the surface. So in order to implement all the previous code we have in the first example, the procedural one, in the previous example, on the procedural example, we had to do the manipulation on the data and this two procedures, the API and the database. We had to do it through the data transfer object, which is always in our hands. So we didn't trust them, these pieces of these two procedures. We always were in charge. We got the data, put the data in the DTO in this container, give us the container, let us transfer this one container to another, and then save that container to the database. In this case, it's not like that. I'm just jumping 2 slides back. We're just building an object and saying how it should, what is it? We're answering the question, not how it should work, but what is it? We're saying you are a database book, and then there's API book inside you. And now work for me. And now I'm going to call you the method title, for example. And then when I call you method title, something will happen inside you. Something means that you will go to the API, and then you will save to the database, and all that stuff. That was my last slide, so I just want to ask, what do you think?
I have a few questions.
Yeah.
Isn't it a little bit surprising that when I call save title on a DB book, it saves it to the database?
It looks like a side effect, yeah? So you're not expecting that.
It looks like, yeah, an expected artifact.
So the question is that if we are making this database book, a DB book, and then I call the title, it gets the title from the encapsulated book, and then saves it, and then returns. It looks like something strange behavior.
Yeah,
right?
so I'm thinking that I will get the title, but
yeah.
I don't know that it will be saved in the database. And on the other hand, if I want to save this book to the database,
you won't explicitly say save.
That sounds like an action, which is, you said,
Yeah,
which is not okay.
which is procedural, yeah.
But like, I don't see how it can be implemented in a clear way. So
I think that's the clear way. I think that's a good question. So you're still thinking like the person who wants to be in charge of what's going on. So you want to see exactly what's going on. Like if I say save, it goes to the database. If I don't say save, it shouldn't go to the database.
That's right. But
yeah.
I'm saying that it seems like it's a little bit not single responsibility principle. So I'm calling title. I'm supposed to get title, but in the same time I'm saving it to the database.
Yeah.
So 2 actions happening in.
It could be many more actions. It could be many more actions. So you can build a complex object. The object could be bigger and bigger and bigger. I mean, more and more complex, and more functionality could be there, but you don't see it. So it's not visible to you. And it's still single responsibility. It's still, I mean, because there are two objects. One object is called database book, another one is called API book. So each of them are responsible for different things. The API book is responsible for getting the data. DB book is responsible for saving the data. But when you're calling the title, yeah, it happens like a side effect. So we're not expecting that. So why on the call for getting something, actually the saving is happening.
Mm-hmm. And let's imagine the situation when we have a requirement to implement it vice versa. So we get the book from database and save it to API. How would it look like? Should we change the methods?
Then you do, yeah. Then we implement a different database book, which will look differently. So the database book will look like a book which knows how to get the data from the database, and
so
then
use a different class name. Right?
Yeah, different class name. Yeah, I would say so. Yeah.
Okay.
How is this different from? How is this different from like an active record pattern? I mean, the active record pattern basically states that the objects also contain the functionality that it has to do it. For example, in your case, you have written a DB book. It represents a object from database, but it also has all the other methods called the save and all that. And there are already libraries which support that active record pattern. However, it has like programmatically failed because developers are unable to understand an active record pattern and use it in complex enterprise solutions. And that is why a hibernate type of solution where like you separate out the POJO, you separate out the repository service, which is doing it, has become so popular. You know,
Yeah. Who knows how hibernate works? I think some, yeah? Okay, the hibernate is a library, just a few words. The hibernate is a library in Java which is based on this idea of data transfer object, right? So the idea is that you always have the engine, the so-called session in hibernate, where you come there and say, I want to retrieve something from the database, retrieve it for me, and it returns back this data transfer object. It's the really container of data. And then you look at this container of data, you modify something there, and then you say, put it back to my database. And the engine, so that's a session, puts it back to the database. That's, in a few words, how the hibernate works. And it's really so popular, mostly because, I'm answering the last question first. So I think why it's so popular? I think mostly because this traditional understanding of the procedural understanding, procedural programming, procedural mentality is, well, it's not easy, well, it's easier for young programmers, because when you start learning programmers, they start teaching you procedural programming. That's easier to understand. And that's why young programmers, not really professional, it's really to jump in and understand hibernate faster than anything else. And this is how hibernate works. So the session is here, that's a big, huge engine called hibernate, a lot of code, and then a very simple, tiny container of data with no code. It looks exactly like our objects, setters and getters. And now what is active record pattern? Active record, actually, I think I just wrote an article about active record. I'm going to publish it probably next week. So, which says that active record, it's called active record is even worse than hibernate.
Okay.
So I think that active record is even worse approach than this hibernate, and let me explain you why. So the hibernate is doing, this is the session here and DTO here. So we can clearly see, and we're standing here. So we're looking at them both. We know that this is session, we know this is DTO. The active record, it gets this code, a huge amount of code, defines a pattern class for the DTO, a pattern class. Like they start using inheritance. And they put a lot of code into the pattern class and provides the same functionality which was before here, and we saw clearly that the code, that there's a save, for example, function, or update function is here, or load function is here, or fetch function. So we knew that there are some functions in here, and we knew they basically belong to the hibernate. And this is okay. I mean, it's not okay, but we knew what's going on. And now they put this whole stuff here in the pattern class, and they start calling this DTO, which is still an Anemic object. They start calling it a normal object, because a lot of functionality stays in the pattern class. And for us here, the users of this Anemic object, it looks like this functionality is implemented in this object, in the DTO. And now we don't know what's going on. And now we think that the save method, or update method, or load method, actually belong to this poor container of data. But it's still a container, because when I'm calling function save, the call goes through into the parent class, and then the parent class comes back and uses this container as, again, a dumb, simple container of data, gets the data out of here and does something here. So it's just a way through, technically. Am I right?
Yeah.
It works technically like that.
Yeah.
So now I don't know, and now as a programmer, it looks to me like, wow, it's object-oriented programming, because there's no session anymore on the side. I don't need to talk to two pieces. I talk to one. I talk to this DTO, that is object. But this is basically an abuse of inheritance. Inheritance is not like, I mean, they're just abusing the whole mechanism of inheritance. They just put a lot of huge engine of hibernate. They take it from here, they hide it from us, and put it on the parent class. And now it looks for us like, yeah, I have a method update on my object. So I'm calling update, and I think like update will update me. Yes, it will, but it just will go through to the parent. The parent will come back to container, fetch the data, and still use this container as a dumb container of data. So you see, that's the problem.
Yeah.
So they're not really solving anything, because it's still a container. There's no logic in here. Still, the container doesn't understand how these save load operations are happening.
So are you suggesting that by using dbbook, the your pattern, not to use any third-party libraries, because
There are some libraries which you can use. For example, for SQL, there are, for example, this library JOOQ, JOOQ, probably heard about it, which is quite popular library for actually doing SQL requests from your object.
Okay.
So you define your object. The object it has the semantic. The object knows what's going on. It's not just passing calls through. It's not a dumb DTO. It knows what's going on. It calls the library, and the library does the work.
Let me ask the question in a different way. How is your how is the recommendation that you are doing, has this been applied for in a large code base, and have you seen is if this programmatic applying to a large code base, 10 developers working on it, can this scale to that levels?
I haven't seen large enterprise software done like that, because I don't think that's probably the purpose of this meetup. You see not so many people here, so we're just starting that. If you go to some meetup about hibernate, it's going to be probably a few hundred people.
Yeah.
So definitely this approach is kind of I would not say it fresh, because people are talking about that in some books for years. But in practice, yes, we have hibernate. We have really popular software which is done with the Anemic model. So I haven't seen that on a large scale, but I've seen my applications, and I've seen a few applications of people who who actually working like that, but they're not huge. So if we're talking about how many data objects which are actually connected to the database, I would say 15, 20, 25. That's the size. Enterprise applications, they may have hundreds of these Anemic objects, hundreds of them.
Yeah.
So I haven't seen it on a big scale. And that's the question where people keep asking me sometimes on the blog, and when I'm saying that, they're saying, yeah, that's funny. I mean, it's good for a small project, but show us something big. Because the ORM solution, the hibernate, they work on a huge, massive, well, we have examples. With this approach, I haven't seen many examples, but it's just probably a matter of time. I hope so. I hope so, yeah.
How is this code can be tested?
Yeah, for testing, it's even easier to test that. That's a good question.
We create a big object, we compose a lot of things in one thing, and then our test should be integration test, which tests in and out, and we are not able to test separate components.
That's a good question. No, the question is how we can test that, and whether it's possible to test if we wrap and decorate objects and objects and objects, and it becomes so big.
Slide number 9 or 11, where this one. So when we write a test about the component that uses this line of code, it will also execute API hook and the code inside of DB.
Yes,
so
exactly.
we're not able to isolate this.
Yeah.
Right?
In this case, if we want to test the whole line of code, then yes, it will go to the API and will go to the database. But look how easy it can be tested. If you want to test just the database functionality, you just give it a fake object over here, or mock, or something. So you give it like a you understand, like an object which does nothing, so it doesn't connect to the API, and then you just test the functionality.
Yeah, but what if you use this line not just as one line, but you also have
Test the whole
other
thing.
lines, yeah, and it's 10 lines that look like this, and you want to test that all this logic together give you a correct output, and you don't want to call a database, and you don't want to call API to this test, and you want to just mock this API, but you can't because you directly create API books here. So there is no way to mock it. There is no way to test it, how it's going to live in a large project.
If we want to, that's a good question. So let's say this is the one line of code, and there are 5 lines here and 5 lines there, yeah? And we want to test, and we just run the test for a whole 11 lines. Yeah. And then, okay, we can't just, and it will actually go to the API and it will go to the database. I mean, connect and talk, and it's going to be integration test. In this case, obviously, of course, but if it's going to be 5 lines before and 5 lines after, then it doesn't matter what's here. This code, the procedural code. In the procedural example, it will be exactly the same. It will be not just 1 line, but that 4 lines we have.
For example, I can mock the repository and I can mock the API.
But it's going to be like this. This is procedural code.
Yes, and here I can provide a fake API and I can provide fake database. And it will not execute real API. It will return me a fake object when I call a fetch. And it will return don't save anything, and just return nothing if I call a save method.
But how do you mock this? This is just a hard-coded link to the API.
why it's
This
will be
can be
recorded.
injected.
It can be injected,
It's
yeah.
the same way it can be injected into
Yeah, if you want to inject it here, you can
No,
inject it
can
there
inject
too.
it into object.
What is
that's
it?
in the
No, like
replicate.
it's definitely like the
No,
object
here
in-
when I call this method, the input of this class will have this object API, but so that like it's injected from a container.
So
and
this same thing like this API fetch, it's encapsulated somewhere in the object, like in the API book, and for sure, like you will provide like it's a simplified example, but it would be provided from outside of the object.
So you will
into
not create a API book, you will use some factory?
In that case, I have a question. How we will inject the API into the book?
Well, in this case, look, if this is like, if it's real code, this is a static method, right?
No, it's not, of course not.
Yeah, it's
Okay, but in this
so
particular
it's-
code, this is
They-
static, yeah, but
But
in reality, it's gonna be not a
reality,
static method.
API will be an
API
object.
will be the variable, yeah? Like
It
the,
will be
the
an object,
injected configurable
Yes.
object,
Yes.
yeah? Okay, so in this case, the API is configurable, and you provide it from,
Yes,
from
and
somewhere.
for test I will provide not a real API, but
Mhm.
some mock API.
And in this case, the APIs, you're saying it's hard-coded inside the API
And
book.
yeah, and here I just
Okay, let's make
created
it
one-
configurable too.
how
Let's
we
make
are
it a
going to-
parameter for the API book.
So you propose to provide API into API books every
Exactly,
time
yes,
I create an
yeah,
object.
exactly, of course.
So it's add additional complexity, and this example will not look so easy as it's currently look. So what if my API book not only should speak with API, but what if it's do like
Many more things.
Yeah. What if it's, for example, title should be taken from one service and subtitle should be taken from another service,
Mhm.
and there is also some counters that should be taken from third service. So every time I have to use this API book, I should provide 3 variables inside.
Yeah, of course.
And
Just like here,
imagine
just
how-
like in this code as well.
No, here I just call it from one place. I build this book, and I have a book, and all other code will just work with this book. And in those code, I have to provide 3 different services inside one book every time I need it.
So you're saying we're gonna have API 1, API 2,
Yes.
API 3. But in this case, we'll have API 1 variable, API 2 variable, and API 3 variable, right? So we're gonna still have 3 of them, which will be still configurable somehow. And we just do the same here, exactly. We just pass them here as 3 parameters for the API book, which makes this API book way
Yeah,
more
but
testable than.
There, I need to do this only when I fetch this book. And if I have some other methods that accept an already created book, and they don't care about that this book was from API,
Mhm.
I don't need to provide anything anymore, because I just provide a ready book with the title and subtitle. And they don't need to know about from where this book that was taken from, API, from a database, or from other way, or something else.
Ah,
And
you're saying,
here,
okay, I got it. So you're saying
every
that.
time has this API book, and I have to provide all these things.
So you're saying that, let's say we have this book object,
Yes.
which in some cases it's an object which is coming from the API, and in this case it's configurable, so it has to have all these dependencies and everything. It's like powerful book. And then in another case we need just a book which doesn't need to know about anything about API. It just needs to be able to return the title, which is already coming from somewhere, right? I mean, it has to be way more simple. Just create a number of books implementations. One implementation is called API book, and then another implementation is called simple book, or
Okay, and
plain book.
in a real, like in a quote, I will create an API book, and then I will convert it into simple book, because my other class accepts simple book.
You don't have to, because
Your
if you
class
don't
has to
solve
accept
it-
book. It has to accept, your class, your other clients have to accept book, not the simple book, not API book, not DB book, but they have to accept book. So they all are implementing the same interface. So it's just a book for all the clients. They don't need to know about what the book is like, how the book actually works. It's just a book. The API book is powerful. It depends on 3 different APIs. It's like a lot of code. And another book is really simple. It doesn't depend on anything. It just gets the data from I don't know where,
Okay.
from memory.
For example, and now you need to add a cache.
If you want to add cache, you create another book, which is called cache book.
Decorator.
A decorator, exactly, which decorates some book, doesn't matter which book, and every time we call title here, it checks, do I have it already? If I don't, I go to the encapsulated book. If I have it already, I return it from cache.
And what if this title is, this service that's provided title used not only for book, but also for magazines? And they should share a cache.
Caching service, or what?
And they should share a cache for titles.
Then you create some cache object which knows how to share, and then this magazine, cached magazine and cached book. They both work with the same service. They both connect.
Can you
and
switch
talk to
the
this.
topic a little bit,
Yes.
because we're spending like a lot of time on this.
Sure, sure.
The question is, what if at some point, let's say API call fails? How errors should be handled in this approach? Usually in procedural programming we have this try catch,
Yeah.
and if something bad happens, we do the catch statement in which we like somehow
Mhm.
work with the exception. How it will look like in this approach?
You also
Because-
throw exceptions. Let's say the API book fails here, and we can't get the data from the HTTP server. We just throw an exception, and the exception gets propagated up and up and up and up and up, and the whole stack throws up and to the higher level.
I want to ask you if I make a slight change to your interface, how this changes things and what you think, and it goes back to your question. Let's say the interface, instead of title and ISBN, you have set title, get title, set ISBN, get ISBN. They're methods in the interface. And then you have an API book or a DB book that implements that interface. Take the DB book. So the set title would store value in the database. A get title would query the database for that
Yep.
value,
Yep.
rather than having just a title method that saves and retrieves all in one, for example. And then the API book set and get would be, hosting the data and getting the data.
Yep.
That gets back to, you have this kind of container that you get and set data, but you don't necessarily know how it does that. You're just telling it to do that, and then you.
Yeah, in that case, I would just stay away from set and get prefixes, because this set and get, they're just meaning basically setters and getters.
But they could mean different things depending on the
Yeah, but
implementation.
for most programmers, they mean that there's a container. So if I'm looking at your object and I understand that you have set title, get title, I expect it to be dumb, and just save title into the memory and do nothing else. So if you give me the object, I'm your client, and you give me the object which says set title, I don't expect you, by calling set title, to go to the database. That would be really unexpected behavior for me.
If you have a method that calls title, I also don't expect that it will save something to database.
But you don't have this clear convention that get and set are just returning the setting.
I have a convention that if something return me, then it
You
should
have
not
to look
save also.
inside. the
No, I
method.
don't. I will
Like
not
the-
look inside.
This was an idea like previously of encapsulation of the getters and setters, that it's not like just an access to like some field inside of the object, but you can encapsulate some logic and so on, like do some logging and like whatever. Yeah, so like no one was expecting that it just like pure set of the field. In other case, like just like get rid of getter and setter and provide the direct access to the field.
Okay, so to save title and subtitle of this DB book, I should create a DB book, and then I should call DB book point title, and then on the next line DB book point subtitle. And if I don't do this and I just create a DB book, it will not save anything to database.
That's the idea, actually, in object-oriented programming. If you don't touch the object, it doesn't do anything.
So you
yes.
don't do
Like
anything
creating-
in the constructor.
Sorry?
You don't do anything in the constructor.
Yeah, you don't do anything in the
You don't try to
constructor.
declare this object.
Yeah, you just declare an object.
Yeah, I
just declare,
declare.
declare, and you don't
What
touch
if-
it, it's
okay.
silence.
What if I have 20 fields in this object? How should I make
Save
sure
them all
that
together.
You
all of
shouldn't
them
have
will
an
be
object
saved to
with 20
database?
fields.
So you're saying that we have like a number of properties,
Yeah.
attributes, and then we want to save them all together, not just calling one by one.
Yes.
In this case, that's a good question. In this case, we introduce a method which is called save all together, for example, or change them all together.
What's the difference between this and like, previously you said that's like, this is functionality approach,
Yeah, procedural.
procedure
Yeah.
approach. Yeah. So you still use this approach?
No. Procedural means that first of all we inject the data and then we call somebody else and saying save it. So they're like two steps. In the object oriented, we're just calling an object and saying do something for us, like save everything or save just title, and then everything else is encapsulated. So there's not two steps. It's always one step with object oriented. Because in procedural, the object is a container. It's simple, and then the code which knows what to do is staying somewhere else. So the semantic of these calls are not in the object, they're outside of the object, in some procedure, an API, a database, and a controller. The controller is yet another example of bad design.
Somehow the fields has to be populated, and that is still like you have to set them one by one. Though.
Populated by who?
I mean, DB book has this say title, ISBN, and then you have save all.
Yeah.
You are trying to call
No,
save all.
save all means save all, and all parameters are given in the parameters.
Okay, so
you
you
don't
have
fr-
save
yeah,
all
save
with the
all,
title
and then many
and-
arguments. Yeah, that's what I'm saying.
Wow,
So it
that-
shouldn't be like set, and then save all. No.
Like we have 10 fields on it. That method.
We
becomes-
shouldn't have 10 fields.
On a
No.
Pojo?
No,
on-
we shouldn't do that. Yeah,
Should
All-
have smaller
that's
objects.
too big. Yeah, if the object has 10 fields, then it's something is wrong with an object.
Then you break it down.
So you
into
break it down into pieces. Yeah, you shouldn't be like that. Well, you may have that if you have like a database and there's a situation for you, but that's not a good design. But yes, still, it's better than DTO. Still, having 10 parameters, 10 arguments, and one method save is better than having the data transfer object and then injecting data there and then saving and then giving it to somebody and saying, okay, now you have the data, the container, save it.
Okay, so
That
so,
would be wrong.
So we are in a world where we are creating these big table-based databases where these tables are huge,
Yeah,
like rows of like
hundreds
huge
sometimes. Yeah.
columns
Yeah.
in each row, and we are suggesting not to do that in this scenario now.
No, we cannot just not do. It's not up to us, right? Sometimes we just have this database and we can't just do anything about that.
But it
Just
is becoming more
some,
and more
some
like-
legacy project. But like I'm saying, you don't need to. Well, if you have like many elements, just give a map of values there. Let's say call the method save, and then don't give 10 parameters. Give it a map.
Okay,
there.
fine. Okay, so
Something, an array, a map, a collection.
But somehow the values has to be added into the map. In that case, it goes back to the procedural thing now. Because you are doing map.add title, map.add ISBN, map.add something else, and it's now.
So we create, like you're saying, creating another container, yeah, which is a map.
Exactly.
Yeah.
I mean, say you have save all, you pass a map into it, but you have to put the values into the map, and that still is becoming.
In this case, it's just pure data, so we don't call it class. It's not going to be called a class. That's okay because it's a map. It's an array, for example, or a map. It's just a pure data structure, which is fine as long as it's just data. It doesn't call itself a class. It doesn't say I'm a book.
Yeah.
It doesn't mislead us, but by giving us the information and saying I am a book, and we're just injecting the data into the book and calling wow, it's an object. So this is about our thinking, not about technically how it works. So we start thinking that an object is something which we can put data in and then just throw it away. So we kind of starting to think about object as an anemic object, as a container, which is wrong. If you look at a hash map, you don't expect it to be an object. You don't expect any methods there, right? Except put and get. So, but in an object, you should expect functionality. You should expect behavior. You should expect semantic there. In a hash map or an array, you don't expect any semantic. It's just an array, just a collection of elements. So you just put 100 elements there and say, okay, save them to me. But that's data. That's pure stupid or dumb piece of data, which has no semantic by definition. Well, what the problem is with OOP, with the Java now, is that we get the real objects, we get the real classes, which are supposed to be real classes, and make them anemic, and make them as data. So we convert objects into data, and that's how we jump from object-oriented programming to procedural.
Well, anybody who has created anemic objects is not for the purposes of creating anemic objects. They went for the purposes of making your procedural language to be more readable. It's like a book.isbn was, or book.title is like, it looks very like dumb when you're looking from a very small perspective, but from a bigger project perspective, the title and ISBN is an important characteristic of an object that you want to encapsulate it like that. You could have called it x1, x2, x3, and it would have made no sense to you. And probably in the database, you are saving it in a different way. And that is why, and like an ORM framework or like Hibernate will help you is that like a title has subtitle and a title. You can actually encapsulate these type of things on a Pojo or like a plain object. But what you are saying is mixing a service layer into an object is completely like against the patterns that we are.
It's against the patterns, yeah. And actually, it's really good you mentioned service layer.
Yeah.
So I think this whole idea of service layer is really procedural. So when we introduce so-called service layer and another layer, and then we say this is our objects and this is our service layer, this is the pure declaration of being procedural. Because the service, what is the service layer? It's just a collection of procedures. Who are these controllers or services? They're just procedures who manipulate with the data or objects. Objects should be in charge, not the procedures. So objects should be like primary, first-class citizens, not these procedures who are controlling them. So the service layer, you're right. A lot of these patterns in the books, they say that we need the service layer, and then the service layer manipulate us, and we see like MVC framework, for example. This is not the framework, but MVC.
The ORM framework.
The ORM, the frameworks, and then MVC frameworks, MVC design pattern. It's all coming from there. So we're just trying to move procedural programming into the Java world, and it happens. I mean, it works, but it makes us not object thinking programmers anymore. So which may sound for you kind of surprising.
Yeah, because it's first of all it's very surprising for me, and second of all is like I really wanted to see is like how will this even work with big teams and big projects with a lot of code, and especially in enterprise solutions. I mean, as of now, enterprise code is not good with what we have, the procedural coding methodologies, and I feel like this is going to completely confuse people. Even more,
which is good, I think.
The reason why I came here is because this standard procedural approach doesn't work, because you start project, 2 years pass, and you have project that you should throw away and start from scratch because it's too complex to make any changes. So have you any experience working with this one? So in 2 years, project don't become too complex. It's like
I'm using this approach. I'm trying to. I can't say I know this for a whole life. I just started to experiment with this approach about 3-4 years ago, something like that. So I have projects which actually design like that with this thing in mind, maybe a year and a half, maximum 2 years, and they are live, and many of them are open source. So you can look at them how they look and how they work, and they're still alive, and people work on them. And like I can't say hundreds of people, but we have teams of 20-25 programmers. And it does work. We don't have big enterprise systems like I'm saying 100 tables in a database. No, I don't have that experience.
It's more like for microservices.
It's mostly for microservices. Like the size of a project, which the biggest one which I've done so far in this approach is about 100,000 lines of code, Java, about 2 years of work, about 20 programmers. It's not huge. It's not really small. It's not micro. It's 100 lines of code.
Is it true to say that methods are really concise and like that you have a lot of classes?
Yeah, you have a lot of classes, and the maximum size of a class is about like 200 lines of code. So, and we have the I made a framework, open source framework for web, so web framework to replace Spring, because Spring is all made with the setters and getters. This is really like this DTO is part of the Spring. So I made a framework which is about 300 classes and probably 50,000 lines of code, maybe 40,000 lines of code, and all of these classes are really small. Like probably the biggest one is 150 lines of code, 150. I'm not talking about like 2,000 like in many other frameworks. I'm talking about 150. So that each class you take a look at, you can understand it easily. You can just look at it and just 2-3 methods in the class, 2-3 methods maximum. That's the size of the class. Not like these classes from Android, for example. If you look at the Android, I don't know who of you actually seen Android SDK. Some of the classes are like hundreds of methods, hundreds. So they're huge, massive, not classes anymore. It's not an object anymore. It's just a piece of procedural code, which is so huge. And half of these methods, or maybe 50%, or maybe I don't know, 80% of them just setters and getters. So you're supposed to set a lot of things, and then get them, and then maybe something will be executed later. So yeah.
Go ahead.
Yeah. So that's
How good task coverage have your project?
In this framework which I mentioned, we have about 80% coverage, so it's really covered by tests. We are like TDD driven.
Like if you try to add some new features, how your test will?
We cover everything first of all. So each class we write, each object, like it's a mandatory to have a test. So, and then we add new objects. It's not a problem. We don't. I mean, they're quite isolated.
I mean, you not always need to add a new object. Sometimes you need to modify, logic
existing
of
one.
existing one. So, do you like how many tests you have to rewrite because of this?
The smaller, I think, the smaller the object, the better it is to test. The easier to test. If the object is big, it's difficult to test. If an object is small, it's easier to test. Right? That's
Yeah, but you have no way to mock other objects. So if for example you make some bugs and your test is failing, how many tests will fail if I, for example, make a bug in DB books? Only DB books test will fail, or also 2000 test more?
preferably, we want only the DB book to
Yeah,
fail.
of course, but I have a doubt that you will be able to do this with this approach.
But I think we just misunderstand how the mocking, I mean, in our case works. I can explain it again. So in this case, like here, it's always the objects are. Look, here the code is. Here to mock this, you really need to think about, because now the code is, we put two pieces of functionality here. First of all, we talk to the API. Second one, we talk to the DB. So we're doing two things at the same time. So we're doing this part of the code. This first line is talking to the API. The second line is, the last line is talking to the database. So in order to mock this or test that, we need to do something with two dependencies. We need to do something with the DB and the API. We need to inject the API into the test, and then we need to inject the DB into the test. So it's really difficult to break it down into pieces, this code, because it's procedural, because it's one long procedure. Well, it's not long, but it's 4 lines. In this case, we have also the same functionality, but it's easier to break it down because we have one piece here and another piece here. I can separately test the interaction with the database and separately test the interaction
Yeah,
with
but
the
what
API.
about their interaction together?
The interaction together is not testable. It's not. Let's not discuss. It's exactly the same in both cases. Exactly the same. So the interaction together, if you want to test like the scenario which is happening here, like before and after and all together, it's exactly the same here and in the procedural. It's just
You should have to call title rather here, right?
yeah, you call title here. Yeah, of course.
You're saying about some simple way, but what if you have more complex logic? What if, for example, you have input some complex object, and you need to make some manipulation on this object, and then you want to return another object. And this manipulation may be done in a different way. And you don't really care when you want to test these methods, you don't really care which manipulation and in which order you will do. And one implementation is like to do some long processing, like this may be very slow, and another may be very fast, but like more complex way. And you call other objects to do this. And today you take like API books, you do something with API books, and then you create DB books from this. Like you make some procession on title to get a new title, and you want to make sure that if you know what was a book, the title in a database, and then after some processions, the API will accept the vice versa. If you know what was in a database, in API that was returned by API, you in a database will be like exact result, and you don't care about what was done in the middle. How you're going to test this?
It's more about like integration testing you're talking about. If you'd like many steps before the final results show up, right? So in this case, I think for the integration testing, both procedural or object-oriented doesn't matter.
It's matter because you don't want to call a database in this test.
If you don't want to call it database, you need to break the dependency and give some mock or fake.
Yeah, in your example, this is a database. In a real world example, it may be not a database. It's maybe some other method that's like you call there inside and you want to mock it.
Yeah, in this case, the mocking works exactly the same in procedural and object-oriented way, exactly the same.
But you create implementation directly. You can't inject them. In a procedure way, you can inject API and you don't need to.
I see. I understand. So you're saying, okay, you're saying so that here the code is right here, and we just see it and we just inject what we need to inject right into this code.
Yes.
And here we're just making the using operator new, which is causing trouble because we're making new object which we cannot actually know what's going on in that object.
Yeah,
right?
because it's fixed implementation.
Because it's somewhere else. Yeah, that's right. But that's why we need to inject our dependencies into the object through the constructor.
But
Like
you
you're
have
planning
logic
to inject it
inside.
here, you're planning to inject it here, right? The API, for example. I'm doing it exactly the same, but through the constructor.
But you said that your DB book have logic inside, implementation inside, that you don't just redirect it to some other places, like was in a
Active record.
active record, yes, it's
Yeah.
like you have a direct implementation inside this class. So
Yeah.
there is a logic inside DB book, and there is a logic inside API book,
Yeah.
and you want to test, and when you test this class that's called these two classes, you also test this logic.
Yes, that's
So
right.
if there is a bug in this logic, all classes that uses implementation directly will fail also.
That's true.
So instead of one single failed test, I will have thousands of failed tests, and I have to go through all of them and see what is the real reason of the failure.
Why that be a problem?
Because I have 100 tests and I have no
You
idea
have-
what
you
is the
have
reason.
like logs what happened, so you
Yeah.
can go and fix the problem.
But I mean,
But
it
I
would
have
have
to
been
check
actually.
at logs of 100
It's
tests.
like C++. You have like 9,000 errors. You fix one semicolon and everything is fine.
Yeah, but we are not writing on C++, we are writing on Java. I have 100 tests and I have to go inside each of them while I don't found them.
You have to go
exact
to one of
one,
them. You fix
no.
the issue, you retest, and everything is fine.
And probably in some cases, if you fix one semicolon and instead of 100 you come to 50,
Semicolon is like
say you come to 50, you still probably are having, something has been broken. And that is why all the other 50 tests are actually failing.
But how I should know what is the actual problem if
Because you're
100
changing something, so this failure is causing by what? So
But
you
I
start,
may
you start
change
changing.
not just one line, I may change thousands of lines.
Yeah, but
Yeah, but you know exactly what area are you fixing. So you're working with some
No.
area, and then
I'm implementing a new feature, and my feature may affect thousands of files.
yeah,
you just change one, just fix one test, and everything else will just work.
But
mean-
how should I know what is the reason of failure? Because
Just pick one
thi-
test.
in this test, I call this database book, and the results, like when it's fail, it's maybe just saying
So-
that, for example, the number of elements in collections is 10 instead of 11, but the actual problem is a title now return the wrong title, and this is why it was filtered out in some other places, and the number is wrong. And to find that the title is really wrong and not the number, I have to go deeper, debug it, and found that, oh, actually, the title is wrong, and I filter it here.
you are assuming your statement on saying that if you write a unit test case for this one thing, and if you change the main code, and if this one unit test is going to break, everything is going to work if you just fix this one unit test case. Sometimes when that is not how actual code works, even if you change one piece of code and you have not written unit test cases for any other classes which are actually using the real objects, your unit test cases are giving you a false pretension, saying that the whole thing is correct. So but that is not the truth. In a true scenarios, you changing one line of code, if it actually is breaking 50 classes, that means that there is actually something wrong in all those 50 classes and all the 50 services that are actually using your main object. I think that unit test is like assuming that you fixing your unit test cases will actually solve, and if you can push this code into production, that is a total mistake. It's like you are actually changing one line of code and breaking something, like 50 test cases are failing, there is a serious problem. And you have to fix all of them. And probably that the logic has to be redefined.
No, it's not a serious problem. As I said, for example, I make a mistake in a get title methods, and I return a wrong title. For example, I add a variable at the end,
Yeah.
and now it's the test for DB book will failing because I return a wrong title. But all other tests that use this DB book will also fail.
Yeah, I can see both the scenarios where your test case failure and you start from the wrong side of it, and you suddenly are like why this one case is suddenly changing, like made you start from a different point where you are not able to figure it out from the test failure to come to like, oh, this exact thing actually causes this. And say even if you like revert back and your test cases have passed, and now you are like, okay, you're fixing it, but I think that assuming that unit test cases is I feel like injected objects it will help you in like more like elaborated test cases, and it will give you a much more better picture. But like if your unit test case, one thing is failing and it is causing hundreds of failures, and even if you fix one thing and still you have 50 of failures, there's some.
No, it's not about I fix one and I still have a failures. It's about like when I have a 1,000 failures, I have to find, I have to take one of them and go deeper where I don't find the problem. And if this will be one single test on a DB book, then I definitely know where is the problem. But if there is too many tests, if I take a wrong test, it may be a very deep past before I found that the actual problem is inside DB book. It may be a class that contains another class that contains another class. It's like 20 classes inside. I've only found that all DB book return a wrong title. That's why. It's
So
about
okay,
here,
makes sense.
here,
Yeah, makes
here.
sense. But okay, let's say you're right. Okay, but what's the opposite solution? So you're saying that if we make our objects smart enough, so they contain logic inside, they're not just containers anymore. They're not just dumb data holders. They are smart enough. You're saying that in that case, different pieces of code may touch them, and that's why if we make it like if they stop working, that many pieces of code stop working, right? That's the point. So you're saying we're not anymore containers,
Yeah, if you
we are
create
smart
them
objects.
directly, if you create them directly using new keyword,
Yeah, exactly. Yeah,
yes,
exactly.
then you
So
can't mock them.
yeah,
and
we're just kind of attaching many pieces of code to the functionality, which may be broken, and then these pieces of code will also be broken eventually,
Yes.
right? That's the problem. Okay, that's one situation. Let's discuss another situation. Let's say we're writing procedural code and we have just containers, right? Just not objects, but really containers of data. They have no functionality, so no matter where you touch them from, you're not going to break anything, right? Because if it's just a book with just ISBN and title and nothing else inside,
Yes.
what can go wrong, right? Nothing. And then, but we still have this functionality somewhere. The functionality which in the first case was inside the book, but now where is it?
it's in
it's-
some other class.
In some other class, right?
Yeah, but
So-
I don't create this class directly using new keyword.
How do you
I-
create it then?
I use a container injector.
Yeah,
It will
but
call-
it's gonna get called new.
Yeah, there's still new over there.
No,
How is it?
How else you can create
it's
an
always will be provided into constructor of a place where I use it, and those class also will be provided into constructor on other places that it's used. So every time I create a test for some object,
object? Yeah.
it has some logic inside methods, and every dependency is provided into constructor.
Like a
So I
global
can
Yeah, but
walk
still we need
whatever
this
I want.
functionality. Look, we need this functionality, right? Like in the first example, we have the object as
But when I test this class, I can mock this functionality. I don't need to call a real implementation of this functionality if I test in the class.
No, in the first example, we had an object which was big, right? With a lot of functionality. And then we had like 5 places in our code which made that object by new, and that's why
No,
there's
they
5 toxic
They
places,
don't-
like potential problems here, right? 5 potential
Yes.
places where the potential bug may show up, right? Because new, 5 places where we have new.
Yes.
And then the functionality is here. That's one example. Let's take another example. We have this, the object is simple, it's just a container, no bugs there, but we still have the code, right?
Yes.
We still have the code, and we still have these 5 places.
Yes, but they don't use a new keyword there.
They don't
They
use
are
key,
s-
okay, they don't use new, no problem, they use through the container.
Yes.
Okay, we make a mistake here.
Yes.
They also still will
But
fail.
no, because
No?
when I test them, I don't use those implementation.
Okay, don't use implementation here as well, in this first
I
example.
can't because they created using new keyword.
I think she's talking about mocking. So in the first place, you are able to mock this broken functionality. In case when we do new, we can't. For example, if you go to the slide of API book implementation, let's say we could throw runtime exception in the
Yeah.
middle of this class, and then in that case, both API book will fail and DB book will fail, right?
Mhm.
Even if we mock database. Is that what you were talking about?
No, I think I understand the problem. So you're saying that in this example, we have the object and then 5 new, you're basically against the new operator.
Yes.
You don't like the new operator everywhere, right?
Yes.
You kind of feel this as the potential problem. But you can replace this new operator by injected dependencies.
In your implementation,
Yeah.
you can't.
Why not?
Because I directly create an API book.
Yeah, you created the new
And
by
API
default, but you
contains-
can introduce another constructor which will accept your dependency. So
In
by
this
definition,
In this case, implementation of the methods that accept load a title will be not inside API book, but inside service.
Not service. So you're saying that we create
Yeah,
In
one
some
global
other
singleton
project,
or
in
something.
some other object, that's I will mock. This is the only way. If I want to mock the code that's do a HTTP request, I need it to be in a separate object.
No, but wait a second. In the first example, we have new. In this example, you're saying we have the dependency injection container, yeah?
Yes.
So we automatically. So use that as the same as well here. Don't make new.
But you said that in your implementation
No, we can replace that. We can replace this by this. If you don't like the new operator, use the dependency injection container.
The problem not in a dependency injection container. But the problem is that here you want to create API book,
Yes,
and the API book inside contains code that make HTTP request.
yes.
And I want to be able to mock HTTP request.
Yeah, but in your example, exactly the same.
You're not going to mock HTTP request. You're going to mock implementation of API book in your method. And you can inject factory, for example.
Yeah,
So-
then I have to inject a factory every time I
Okay,
want to
it's
create a book.
exactly-
Yeah, exactly what you're doing in your
Yeah, it's
current.
really just a question of implementation. If your approach is okay with injecting factories, for example, instead of direct
Yeah, sure.
creation with new,
Yeah.
you're absolutely okay because you still can just replace creation with using create something from factory, and you can
Yeah.
isolate your dependencies just by mocking factories.
I'm not suggesting that new. I mean, in this talk, I'm not saying that new is better than the dependency injection, even though I think so, but not for this particular discussion.
Then it
So-
will be a DB book factory create book that accept a API book factory that create a book.
No, it's
And this line will be so large and this will be not readable.
not really. It will be just DB factory create and into like that just interface. So
He also call API, so it will be API factory get also.
not really. Your intention is to create DB book, right? From some kind of book. You have interface book.
Yeah, but for his code here, it will be DB book create,
Yeah.
API book create.
So you have DB book factory, and you want to create DB book here. So you will write DB book factory dot create, and you will pass your book. In that particular case, it will be API book.
Yeah, exactly.
And in your test, you will just write, okay, I'm mocking DB factory book, DB book factory dot create
Mhm.
that accepts any book and return some kind of.
I would like to see these tests and how
Yeah.
readable they will be.
Yeah. I kind of understand your problem now, what you're saying.
So yeah,
So of course, with this approach, we will have way more objects and way more new operators. Yes. And I'm generally against this DI containers, but if you want to use them, you can use them. But it will be, I agree, it will be a little bit more this workaround, because with the procedural code, it's way easier because there are less objects, and then we need to less this mocking, less injections, less of this DI operations and everything. So with this approach, with the OOP approach, we'll have a lot of these new operators everywhere, which is, in my opinion, good. But from the point of view from people who are coming to that, from procedural programming, it may look strange in the beginning. But
What
it's
it's
about
not
the
about
procedural
procedural programming.
programming,
It's
it's
about
about large projects that have to be tested.
It's about inversion of control issue. So we have inversion of control containers to solve this. So it's very old issue. So we're solving that with dependency injection and so on. But with overuse new, we're just coming back to that age. So, and if we going to replace all our news with factories and so on, it's pretty questionable if we still have readable code. So it's really not, from my opinion, a good idea to just say, okay, let's use new everywhere. So, and we will have readable and clear code, because it will lead to another kind of issues. So,
Can you talk about perhaps the advantages or disadvantages of splitting up the read and write behavior in a single object? So your book, whether it's a DB book or an API book, will read from the DB, read from the API, or write to the API, write to the DB. And when you were talking about how there's this confusion where you call title and it saves and it returns a value, are there advantages to defining two different interfaces where the interface doesn't represent necessarily the entity, but the interface represents the behavior as well, and the reading and the writing is done by separate objects.
Well, I would say, I can't say there's right or wrong approach, but I would go with the object has to know everything about itself. I mean, writing and reading all together. So this is kind of single responsibility principle, which means that there's one thing, one object knows everything about itself. If you break it down into pieces, like this object is writer, this one is reader, for example, and this one knows how to read, this knows how to write, I think it's in general the wrong direction, because you eventually you will have a problem of how you avoid duplication of some pieces inside these two different branches of reading and writing. So I'm in my code and my projects, I always have, if it's an object, this object knows everything about itself, how to write, how to read, who it is. I mean, if it's a database book, if it's a book in a database, then of course it knows where it's stored, and how to retrieve from there and how to save there.
I'm just thinking about how if you split those roles up potentially,
Yeah.
you might be able to define an interface that handles kind of the batch operations better, because you know, if you're going to post some data to the API, I mean, I know that you're trying to get away from the implementation, but you don't necessarily want to make two calls to the API. You want to post both fields with one call, or even if you're writing the database, I mean, that's not as bad, but you might want to update a whole row. And if you have a single object where your methods represent these fields and a read or write operation, whether it's to an API or a database, it's more difficult to batch, say, a write, unless then you start defining these special case kind of save alls, set alls, and maybe that sort of naming or action doesn't apply to all books. You know, if I have a book that is just a memory, a book that in memory, what does save all mean? You know, but if it's a DB book, well then that might make sense. So that's why I'm thinking maybe different readers and writers for different cases.
Interesting question. I don't have an answer. I mean, I would design them together, but maybe there are situations where, like you just mentioned, maybe there are situations where it doesn't make sense to put them together. But in I'm just trying to remember what I was doing before, and it's usually like all together. So if it's an object, it does everything. If it's another object, it does everything. It's an interface. We're talking about interface, and there are implementations of them. And then some implementations may say that I don't need to implement the writing part, for example, because there's no writing there, so only reading. In that case, I just throw exception on the writing methods, for example.
Okay.
And another implementation is different. But when you look at the interface and you don't care about the implementation, just look what it is, you just have to, I mean, I'm expecting to see everything. I don't want to look at the two different implementations and think, okay, who is the book? It's a book, readable book and writable book. That would be strange to me. I mean, that's not really good.
Okay, I don't have a stake in the ground. I'm just
Yeah.
trying
I don't
to-
have a
to
full, I don't
play
know, I don't
the-
know, there is no like right and wrong, probably. So maybe there are situations like I'm thinking now, for example in Java, input stream, output stream. So maybe that would be strange to have a stream, right? And then the stream knows how to read and write. Maybe in that case it
That's a
makes
good
sense.
example,
Yeah, so like
yeah.
input stream definitely is just for getting the data, and output stream is to writing this. So, but maybe there is like like a socket in Java. In socket you can get the input stream out of socket and output stream.
Mhm.
So the socket is something which you can write in both ways. But input stream is something you can only input. So there is
So
different.
maybe
situations.
the book holds a reader and writer dependency.
Maybe the book is also depends. Yeah, depends on the use case. So in this case, there's no right and wrong, I think.
What are you going to do if you have different entities like books, magazines, video, and other things, and say all share the same logic, how to read them from database? Like they're exactly the same and it's like large.
That's a good question. In this case, you introduce, so you have like, for example, like you mentioned, you have a book, for example, a magazine, and a user, for example, and they all are connected to the database, and we have the code duplication, like writing the data, and they look similar. They're not going to be exactly the same because different tables, for example, and different like columns, but it will look close to each other. For example, we're using JDBC in Java. The JDBC, to read something, you're going to write like 20 lines of code. and then you write exactly the same 20 lines of code in another object, which is, they look very close to each other, right? So it just doesn't make sense to repeat them again and again. If you have 50 objects, that would be really strange if you keep repeating them. In that case, you still look for the user, you still keep the objects like that, but then you introduce some library which will help you to get rid of the code duplication. For example, there's Juke library. Or for example, you can write something on top of JDBC by yourself. There are a number of libraries. There's Spring template or something.
Or
There's
just
some
create
libraries.
a new object, or create a new object that holds all that functionality and passes it
Something
as a
inside. You
dependency.
create new objects for inside, yeah, which is not visible for people, for the users. So the user is still talking to the magazine and to the book, and they don't know that they use some supplementary objects which help them to retrieve the data from. For example, you can introduce an object called database and a table and a raw and a query, something like that, to manipulate the database. Or you can use some existing libraries, but for the outside, you don't show that. You don't show that how you solve the duplication problem to the outside world. For the outside world, you still have 50 different objects, and they talk to you, and they don't care about what's inside. But inside, there is duplication. How we solve it? By introducing new objects which help us to, like I'm saying, for example, object table and object database, and object raw, or object query, or something like that.
And what will be the difference if I call this object service, and the methods I say call save, and I provide him myself as like this?
I would stay away from the name service, because
What I
again,
mean is like currently in our way programming, we have a service that accepts entity and send it to database.
yes.
And you say that like entity should have a method save instead. And in this case, we have entity with method save, and we have 10 different entities, and they all have the same code for save.
Yes.
Then introducing an inner object that they redirect logic. So why we can't just take our old service and just call it inside these methods? Like why we need
If you use it inside and you use this service inside, it's not really a big crime. I mean, if it's inside, if you don't show it to your users.
Then I don't understand what's the difference between this and active records that was mentioned.
That was my question.
Yeah, because they do exactly the same.
Because what's the there is no technically the active record. What's the difference is that active record is lying to us. The active record is telling us that this functionality is part of my object. What
But
you're
in this
suggesting is
case-
going to stay outside of the object.
No, they're the same, exactly the same, because I take a service and I call a save and provide myself there.
But the service is a separate object. It's not your parent class.
No one cares about implementation.
Well,
I see
yeah.
contract of your object, and I see, okay, it's book, and it knows how to save, how to load. It's what exactly active record says to us. We have some kind of object, and we know how to deal with it from point of storing or something else. And exactly the same situation in your approach. I take a look on contract of your DB book, and what I see, it's book, and also it knows how to save, how to load. Probably if we are talking about rich domain model, it can publish or whatever domain needs. But I see contract, and it's the same for active record. So it's object plus some interactions from business perspective, plus most questionable part, some interactions with save, load, and other stuff, which no one really cares about, because we have some process of publishing, for example, book in Amazon, and we really don't care how we're going to store that book. So will it be database or Amazon Web Service or something else? It's not business need. It's not domain. It's just
Well, the user,
technical structure.
of course, the user doesn't care. Yeah, the customer of the book doesn't care. The customer who is calling this save method doesn't care at all. But I'm talking about the developer of the book. So from the point of view of the developer who is making the book, it is important, I think, to understand what's going on. Because if it's your parent class, then you're kind of, that's like I said before, we're kind of lying to us. We're pretending that this is part of our class, and we think that we are in an object-oriented
Hold up.
world.
What is parent class?
I mean, the class we inherit from. That's how active record works.
So active record can be implemented in different ways. Really, it's just saying about what we can guarantee about our object. So still, I'm looking at object and I see that it's really domain book with some domain things, domain behavior, and also it says me that It can be saved, it can be loaded, and so on. Same for active record. Where is the difference?
The difference is that it stays in the parent class. That's what I
What is
don't
the
like.
difference if it's a parent class and
What?
it's like private methods, or it's in a different class? It's I accept into constructor and it's still in like.
The
in
difference is
private
that the way they use your object. So if it's a parent class, then your object is a container of data. Because your parent class is using you as a container of data. That's the problem. So you are opening yourself to somebody. So you're not hiding data anymore. Because your class book is open. Because somebody, which is a parent class or an engine, it doesn't matter. A hibernate engine or an active record. The active record stays on top of you in the parent class, so you inherit from it. And then when the call comes in here, then the call goes to the parent class. And the parent class returns back to you and saying, okay, now guys, you are the container for me. I don't care what's inside, I'm just getting the data from you and using it. The
And
same engine.
how you're
hibernate
going
is
to
better.
implement a
Yeah.
class where you're going to store a common logic for saving
The
object?
class will, the object will decide what data to provide to the engine.
How exactly you're going to do this? If I have 20 fields in my class,
Yeah.
in a magazine, 20
Yeah.
fields in a book, and 20 fields in a video.
Yeah. Then let's say we have a method save, and
Yeah.
the method save is called, and I am the book. So the method save is coming to me, and I decide what data to combine, and then I'm going to the engine, to the database engine, and telling, okay, now guys, you make this SQL query and run it for me. So I'm not like asking parent class to come back to me and pull the data out of me. I'm building the data. I'm building the request for the engine, and I'm coming to the engine. I'm in charge. I'm the king. The object is the
But
king.
we started with the thing saying that we have 50 classes
Yeah.
where the save method looks exactly the same on all of them.
Close, not exactly the same, but they're very close.
Yeah, they're very close. I was like, so you're not doing anything. We're just saying we are pulling all together into a parent class, and from this book, we are calling that parent class a save. It's the same as an active record save.
The composition is better than inheritance, where instead of putting all that that common behavior in a parent class and then inheriting from that parent class, put it in its own separate object, and then pass that object in as a dependency through the constructor for that book class that's implementing the book interface to use as its own to make the save itself, rather than going through inheritance.
So what you're saying is when you call book.save, it's going to call the actual save, which is going to call parent class.save?
Nope, there's no parent class.
It shouldn't be any parent class.
There's no parent
It
class.
shouldn't be any
It's-
parent class.
When you construct the book, the DB book, you're gonna pass into the constructor as one of its
Dependency.
dependencies a database class, a
Something.
database object.
Okay.
And then it's gonna hold that database object as an instance field, the book itself. And then when you call save on book, the book is gonna take its database instance and
Exactly.
call database dot
Yes,
put
exactly.
these fields.
And this
rather-
call is in call, and then and only the book is in charge of this call.
Right.
The book
There's
knows
there's
nobody
no
else.
inheritance.
Yeah.
There's no parent.
Nobody else can touch the properties or attributes of me. I'm the book. Nobody can see what's inside of me. Today there are properties, tomorrow there is something else. Nobody knows about that. They give me the database as a parameter for my constructor, and I make the decision when to call it, what parameters, what to provide there, and how to ask the database to run something for me. That's exactly how it should be. Yeah.
Why do you want to call save?
On the book.
I mean, in any case, like save is some sort of.
Yeah, that's another
Yeah.
story. That's also wrong. Yeah, we shouldn't have the save method. That's also wrong.
What
But
if you have a book and you have 10 books and you need to save them together?
in a transaction?
Yes.
That's probably the discussion for the next. We are running out of time, but that's a good question. Yeah. Then the situation gets more complex, but it's also possible. Then you create a more complex objects, which you call like the batch, for example, or books, the multiple books, and then you define operations on books, not on one book. But then you define a collection of books. You define, not the hibernate defines, not you just put the objects together and say this is a collection, now you understand how to work with it. But you define the batch operations.
What if your batch operation is same for any entities that you may have, like you have 10 different entities.
Then
and
you
can-
resolve this duplication somehow, by new libraries, by new code, somehow.
Passing
we-
in the dependency.
Yeah, but we have to finish, we're running out of time.
Alright.
So the
But-
whole point of this is to reduce complexity, is it
To
right?
reduce, well, in general, yes, the object-oriented programming reduces complexity, I believe so, and increases maintainability, in general. And get rid of that problem which you just mentioned a few minutes ago, that the more the code, the bigger the software grows, the more difficult it is to maintain it, which is everywhere, which is in most projects. And to get rid of that, we need object-oriented programming, and the real object-oriented programming, not just the word class. We need real objects. Okay? Thanks for coming. I'll see you next month. We'll try to get bigger. Let me take a picture of you. So we can post it.